fine. Double check the amount of space I have on the drive. I have 17 gigabytes. It's good for about 10 lessons. So we're good to go. All right. So now that we're good to go, we'll start off with something that is not entirely related to this class, but it is related to computer science as a whole. So I'm going to start with that, just so that people have a little bit more time to stream in. This is the power server. For those of you who have taken web design classes, you probably know the power server because you have an account on the power server, so that your professors can grade your homework assignment. But this is also where I have my WordPress, and so far nobody else has stepped up to the plate and say, I want to write too, or tag, your writing sucks so badly that I will go ahead and contribute so we don't have to read your stuff. And nobody has stepped up to the plate yet for that reason. Okay, so this is kind of something that I wrote this morning right before class, because I was working on something, and I just thought, hey, maybe people should kind of read about this too, because it is kind of important when you want to be a computer science major. So the question is, whose baby is this? Okay, and this being computer science, okay, as a field. There are two giants in terms of contributions to computer science, or as founders of computer science as a field. The first one is Alan Turing, and the second one is John von Neumann. This is Alan Turing. Alan Turing is a British native, and his main contribution was at the end of World War II. He helped build the first electronic computer for the purposes of deciphering encrypted German transmission. And of course, to us, for this generation, most of us don't even know anything about it, right? But the contribution is really major because the British or the Allies were able to know what is going to happen because they can decrypt the encrypted transmissions of the German. So they know when an invasion will happen. They know, the forces, how strong of a force, and so on and so forth. Sometimes, obviously, the commanders have to make difficult decisions, because even though they know when the invasion will happen, they don't want the Germans to know that the Allies already knew about this whole thing. So they will still have to stage like regular defense around that spot, so that the Germans don't think, hey, how come there's nobody here? They probably knew about this, and that means something is wrong with our communication. So sometimes commanders actually have to make a difficult decision because they have to make the pretense that the ally did not know about these transmissions. So anyway, this is Alan Turing. You can read about him at your leisure. This is John von Neumann, the other giant. Now, with Alan Turing, he came up with all the theories that we still use today. Has anyone heard of the term regular expression? Nobody. Okay. At some point, you will encounter the term called regular expression. But without the other guy, Alan Turing, we would not have computer programming languages. We would not have the technique and the know-how to deal with programming languages. John von Neumann has a different type of contribution. Without him, we would not have the computer architecture that we have today. Okay, we would not have the architecture of having memory, processor, and so on and so forth. Okay, he's the first one who came up with the concept of a programmable computer. Before him, we did have computers, but they were hardwired. To change the behavior of the program, you have to actually go in and physically rewire components in order for the computers to do something different. He's the first one who came up with the idea of, let's make use of memory and something that can actually change without having to rewire everything inside the box. Von Neumann also has numerous contributions to other fields too. If you just kind of read a little bit about it here, he also he's also into quantum mechanics, hydrodynamics, math, economics, statistics, and so on and so forth. He is called a genius by other geniuses. Okay, if you just read this article, it's really quite interesting because it quotes a lot of people whom we consider as geniuses already. And those geniuses basically say, there's no way they can keep up with this guy. He just intuitively can grasp concepts and process it at a super fast speed that just baffled all the other guys. I mean, those guys are really smart and bright people already, and this guy is just outpacing everybody else. Unfortunately, he died from cancer because most people believe it had to do with his participation of the hydrogen bomb experiments. So that's kind of unfortunate. So you can see that he was only 54 when he passed away. Alan Turing also had a fairly short life. He's even shorter. Okay, he passed away in 54, but he was born in 12, so he was only 42 at the time that he passed away. This guy committed suicide, and you can read about why he committed suicide and how he committed suicide, because none of that is ordinary. Okay, you got to read about it. So anyway, I just want to pop up these two names because I think people should at least know how we got to this point, okay, and not just think about Steve Jobs or Bill Gates, or to a certain and lesser extent, Steve Ballmer. He got us into this mess. Okay, so anyway, that's something for your leisure reading, if you want to. Definitely not mandatory. There won't be any quiz questions, based on that. All right, so we're back to topic 2, and in topic 2, we are done talking about variables, sequences, and how to trace assignment statements. And that's why you have your first homework assignment, to trace a few assignment statements. It's mostly about the convention more than anything else, because I don't think those assignment statements are particularly complicated or tricky. It's just about getting used to the convention, how to use a spreadsheet, that sort of thing. So we are now moving on to conditional statements. We started with conditional statements on Tuesday. So what we'll do today is to kind of finish up everything that we need to talk about with conditional statements, at least to the point where you can do another homework assignment. So now we have 2 concurrent homework assignments going on at the same time. And this document here is new. It talks about the conventions of tracing conditional statements. So we'll definitely talk about that too. And the homework assignment is right here. So what I'll do is I'm going to open it up just so that we can see, we can take a look at the algorithm that we're supposed to trace before we start the rest of the lecture today. All right, so this is the algorithm that we are going to trace. It is a single conditional statement, not unlike the one that we saw on Tuesday, to find the maximum of 2 variables, but that's not the objective of this particular one. I'm not going to say what it is going to do. It is your job to find out. But the difference between this one and the previous homework assignment is there are 3 traces that you have to do. Let me change the refresh rate so that I can bring everything onto the projector, because it just doesn't remember the correct refresh rate, which displays everything. Okay, so it has sheet 2, 3, and 4 as test cases. So don't remember to trace this algorithm using all 3 additional sheets and not just sheet 1. Okay, so there are multiple test cases with this one. So I'll just go back to sheet 1 so that when we need to come back and talk about this, this is where we'll be at. Are there any questions about this homework assignment up to this point? Yep.
Is that the second homework assignment or the third?
This will be the third. The first one is LibreOffice. The second one was assigned on Tuesday. It's called assignment for assignment statements. This one is the third one. It's conditional. So we have 2 concurrent homework assignments, at this point. And from time to time, homework assignments will quote unquote pipe like this. Okay, we call it piping or pipelining because we are starting one without completing the other one first. But I think it is kind of important to do it this way, just so that you guys get a chance to practice the concepts that we have been talking about. Yep.
So each sheet will record a different path of the conditional?
Potentially different, yes.
Okay.
In other words, the path that the program will take for each test case is independent to the other sheets. So you have to treat each one as its own, and start from scratch. Okay, that's a good question.
Sir,
Yep.
do you mind, can you show me real quick for the practice, for the second assignment, like how you found it?
Okay, the second
I got that one
assignment.
that you're working on now, but the second one.
Okay, so let me switch to a student view so that I can see things from your perspective. So I'm going to switch my role to a student. And so this is typically what you would see. You may not have hidden all the tabs like this, but that's usually what I do. There's one tab or one box called Activities. That would be the best place to look for all the homework assignments. And it's not showing anything right now because I probably have not completed the syllabus acknowledgement activity. So let me just check that and see if I have done it. Looks like I have finished it. So then you have to go to the topics. So we are now on topic 2. And under topic 2, we have assignment statements. And this one says that I still cannot do it because I don't have a required score in syllabus acknowledgement. But for you guys, once you are done with that, it would open up. And same with the third one here. So the second homework assignment is here, the third one is over here. And both of these are active, right now. Are there any other questions? Yep.
When is the conditional statement due?
The conditional statement is due 1 week from today, so you have 7 days to work on it. Close to 7 days. There was another hand. Go ahead.
Okay, so has the assignment statement, the first one, or the second homework, it's already passed?
No, that one is still
Okay.
active. That's due on Tuesday, next Tuesday.
Okay, because I got the condition statements, but I guess I passed that one up. Okay.
Yep.
So, okay.
Where do you enter your results? You create
Sorry?
a new tab to enter your result, or just create a new, what do you call it? You open new liberal form.
Okay, let me do my homework. Okay, this will take a little bit of time because I'm gonna have to log out and make sure that I'm logged in completely in as a student, because it looks like if I switch my role, it doesn't work. So I'm gonna add myself as a student, but not using my usual login name. So this will take a little bit of time. I'm just gonna do it as quickly as I can. Okay, there are 3 entries as me. Okay, but it's not my other entries, so that's okay. I'm gonna self-enroll. Alright, so let me go ahead and log out first. And then I'll log back in as a student. So I'm gonna use my student ID, district password, and okay, for the time being, I'm gonna ignore that. Yeah, so I'm not currently enrolled in this class. I'm gonna enroll first because I want to be very specific and make sure that it works for this particular class and not just the other one. The enrollment key, I think, is P300. Yep, it is. Okay, so now I'm in as a student. In fact, when you guys look up participants and other students, you will find 2 of me. Okay, the one me being the instructor and the one me that is being the student. So at this time, I'm going to complete the syllabus acknowledgement first because that's the first thing we have to do. And I'm hoping that all of you have done at least this part, because otherwise you wouldn't be able to access the other homework assignments. So I'm gonna submit it. Okay, that's all done. So I'm gonna go back to the main part of the course and see if I can find my assignments. So assignments pops up now because I'm done with my syllabus acknowledgement, and there are assignments that are currently available to me. So the first thing you want to do is to click on assignments under activities. And I'm not sure whether it shows up, yeah, it shows up in the upcoming events as well, and also on your calendar. So those are the many different ways that you can find your homework assignment. So as far as I'm concerned, there are 4 ways to find your homework assignment. One is in upcoming events, which looks ahead 2 weeks at least. One is in the calendar. You can see the highlight here. It tells you that something is special on that day. You can go to activities, click on assignments, And it will basically list all the homework assignments that are currently active and ones that are, well, the pre-post assignment is for a few topics later, and I have not, hidden this one yet, and that's why the due date is last year sometime. So don't worry about that one. It's not, available for you guys yet. And there's a fourth way. Okay, remember I said there are 4 ways to find your homework assignments. The fourth way is to go to the topic that we are currently in and click the topic itself. And I know this looks really bad because I have all these tabs here and I have to zoom in. But if you look at here, anything that has a hand with a piece of paper on it, those are assignments. So I have assignment statements as an assignment, and I have conditional statement as another assignment. So there are 4 ways to find your homework assignment. Whichever way you want to do it is okay with me. Okay, so now I'm going to do my homework assignment here, which is assignment statements. So I'm going to click on that. And this is exactly what you should see as well, because that's how a homework assignment should look like to a student. So I'm going to do it, but I'm not going to give you the answer, obviously. So I'm going to do it and turn it in just to show you the process of doing it. So I follow my own instruction here. Right click, save link as, and I'm going to remember where I'm saving this in my temp folder. If you're using Google Chrome, once the document is saved, you can click it to open it, and it's not going to cause problems. Okay, so here's my homework assignment. I have sheet 1 here, sheet 2 over here. So I'm going to use my usual technique of using a new window to open up 2 views of the same document. So this way I can look at the algorithm on one side and then look at the trace on the other side. So I'm going to do my homework assignment here, and I'll just say, I don't know how to do this. Don't give me a 0, please. Okay. Well, most of you cannot read it because of the font size. Now we can. Okay, so this is my submission. Okay, I cannot remember how to deal with assignment statements. I'm just gonna say, I'm not gonna do it. But don't give me a 0. Give me some points just for turning in something. Okay, so I'm gonna save it. Okay, don't forget to save it first. And as far as I'm concerned, you might want to close the document first too. Okay, if you close the document, you are sure that the file corresponding to this homework assignment is finalized. Okay, it's not going to be half done. Whoops, I forgot one thing. I did not remember to check whether I have my own name as the author and also the log stuff. So I'm going to double check before I turn it in. And you can do the same thing too if you want to. So I'm going to double check, open up LibreOffice again, go to recent documents, and go to assignment 1 or assignment, just assignment.doc. And I can go to File, go to Properties, and make sure that under General tab, my name appears as modified. And that is not exactly my name because I registered LibreOffice under the name of my cat, or one of my cats. So Red is the owner of this document, and yes, so my cat is doing my homework now. Yep.
How do you see the recorded history again?
To see the recorded history, you go to, there are several ways to do it. You go to Edit, you go to Changes. I just go to Accept or Reject, because it gives you a complete log of everything, and there's a quick summary. You can just kind of go through and go like, oh, okay, that it's already here, I'm done, no problem. Okay. So with this, you can clearly see that the first part is under my name because I created the document, but the last part, the part about I don't know how to do this, don't give me a 0, please, is under my cat's name. Okay, so I'm done. Okay, so this assignment seems good. I'm ready to turn it in, and hope that I'm not gonna get a 0 for this particular homework assignment. So I'm gonna get back to Moodle, and here I say I click Add Submission. Go to File Submission here, click, or you can drag and drop too. But if you just click it, you have to choose the file. Under my temp folder, the file is called assignment.ods. Open the document, click Upload this file. And the file is here, but don't close the browser yet. You have to click Save Changes as the last step. So after you click Save Changes, you will see this screen here. You would actually be able to see the file that you submitted. You can download it back if you want to double check on various things, and if you need to modify it, I have 4 days to submit something else, in case I turn in something that I did not want. Yep.
So if I turn the assignment and say complete, I can pull it back out, update it.
Correct.
And then resubmit.
You can even just delete this one too, if you want to, and say, okay, I don't want to turn in anything at this point. You can click, okay, I'll show you exactly what you need to do. So you can click Edit Submission. You can only turn in one file at a time, so you cannot really just upload another file. So what you need to do if you want to turn in another file is to click on this one, and then you say delete this one. So once you delete the file that's already turned in, then you have the room to turn in another file using the same process that I described a little bit earlier.
And it's not graded until the time.
That is correct. I wait until the due date to grade all the homework assignments. And on the day it is due, I would also give you the solution right away in class. So at 9 o'clock, 9:10 or so, I will be talking about the solution of that particular homework assignment. So even if you don't get the scores of your homework assignment right away, you can at least see the solution to the homework assignment and be able to compare your solution to mine. So you have a good idea of, okay, did I get it right, or did I get it mostly right? Yep, go ahead.
So the homework is due before class?
That is correct. The homework is always due before class. That's usually the way I schedule it, because I don't want people to be in the lab working on the homework assignment when I'm talking here. Any other questions? No other questions? All right. And by the way, the answer that I have for this particular homework assignment is not the correct answer. It would be, just in case it wasn't obvious enough. All right. So, are there any questions about this? Nope. Okay. So without any questions, I'm going to keep teaching, but using my student account, which is okay. I mean, it just means that I cannot make changes to my documents while I'm talking about this. We are done with variables, expressions, and sequences. We are now on to conditional statements. So I will open this up on a separate tab, and we'll start with this part here. What exactly is a condition? A condition is many things. First of all, it is an expression. Okay, what is an expression? Can someone give me an expression in mathematics?
Equation without the equal sign.
Say again?
Equation without the equal sign. Equation without the equal sign.
Equation without an equal sign. Okay, like 5 times 8 is an expression. Okay, it evaluates to a certain value, but it is an expression. A condition is an expression, but it is in a form where the answer can either be true or false. Okay, so a condition is an expression where the answer can only be true or false. So a lot of times we also call conditions Boolean expressions. Okay, the term Boolean means something that can only be true or false. Are there any questions at this point? No questions? Okay. So this slide basically just talks about why we use true or false when we talk about expressions or conditions. So it sounds a lot more complicated than it really is, because at the lowest level, conditions typically use comparison operators. In other words, these are the most basic operators that can form our conditions, at least in the case of computer science and algorithms. So we'll just kind of quickly go through this and make sure that everybody understands these particular operators. Does everybody understand the greater than symbol? Okay, one side is greater than the other side. But remember, it is not a statement. In a condition, we are asking a question: is x greater than y? Or is it true or false that x is greater than y? That is the most important part. So we have greater than, less than, greater than or equal to, which by itself is not a big thing. But because we don't have a symbol greater than or equal to on the keyboard, and a lot of times we use a text editor to input programs. So that's why in most programming languages, they use this particular combination to represent exactly the same thing, which is a greater than symbol followed by a equal symbol. And together, they mean greater than or equal to. Similar for less than or equal to, because we don't have a single symbol like this on the keyboard, a lot of times most programming languages would use this particular symbol, a less than symbol followed by a equal symbol to mean less than or equal to. Not equal to, I guess we don't really have to talk about that, it's just the negation of equal to. But because we don't have that symbol on the keyboard either, now this one is a little bit more tricky because it depends on the programming language. In C, C++, Java, and most other C-derived languages, which would include PHP, Perl, and probably a few others too, they use exclamation point equal to mean not equal to, because exclamation point in those particular programming languages means logical negation. Okay? We'll talk about what is a logical negation later. In Visual Basic, SQL, Pascal, and so on and so forth, they use this really weird symbol to represent not equal to. Well, but if you think about it, not equal to is really just saying less than or greater than, right? If A is less than or greater than B, it means A does not equal to B. So they're really saying the same thing. And that's why in those other languages, they use less than, greater than together to mean not equal to. Last, we have the equal to comparison, and that's represented by double equal in cisp300. In C and C++, it is not a single equal symbol. Okay. In Visual Basic, SQL, Pascal, and most other languages, it is represented by a single equal symbol. So now the question is, in a C++ or C program, if you accidentally use a single equal symbol, what is going to happen? Well, first of all, it is not a syntax error most of the time. So the compiler cannot catch it. The compiler cannot say, hey, this is not a valid operator here. You cannot do this over here. The compiler would just say, yeah, it's okay, because a single equal symbol means what in in C++? Assignment. Okay? And in C and C++, you can have an assignment operator inside a condition, okay, which is really weird and is not exactly the best thing to allow, but it is allowable. So the compiler cannot catch it, but and yet it's not going to do what it's supposed to do, which is comparison. Instead, it will take the right-hand side and use that to change the left-hand side. So it has a completely different effect than intended, but the compiler cannot catch it. So your program will behave wrong, incorrectly, and when you look at the program, nothing seems wrong because it is double equal versus a single equal. I know most of you are not going to register this now because you're not writing any programs in C++ in this class. But when you move on to cisp300, I would say about half of the people in this class will get bitten by this one. And then you'll remember, oh yeah, Tech talked about it a long time ago. Just keep in mind, this is something that can bite you in the next class. All right, so are there any questions about the comparison operators that I think most people are familiar with? No questions? Everybody is familiar with these things? All right, so now we can move on to the next topic and talk about logical operators. I'm going to change the ordering a little bit here, and instead of proceeding with this, which is also what this page is telling us, we'll deal with this later, okay? Because before we deal with this, we just want to use comparison operators and the most basic conditional statement to do something that is useful. Okay, most of you probably still remember the task. Okay, I'm not going to talk when I'm facing backwards because otherwise the voice recording will kind of fade away and it's going to be quiet. Most of you probably still remember what we were working on at the end of Tuesday, which is the logic to find the maximum of two variables and store that into the third one. Okay, so I drew a picture on the board and basically say, it is a special hiking trail for computer science people, right? So we have a hiking trail, and all hiking trails for computer scientists are one way. Okay, you cannot just choose, I want to walk backwards. No, you cannot. So this one has a branch, okay? So at a certain point, the trail splits to two, okay? And now you have to decide, which way am I supposed to go? Well, that's okay, because there will be a sign next to the trail on the little post, and it says X is greater than Y, and a question mark, okay? So this is a sign on the side of the hiking trail, right where it splits into two paths, okay? And you look at a number on your hand, a little post-it, and the post-it says, X has this value, Y has this value, and then you look at the sign here and say, is this expression or is this condition true or false? Well, obviously it depends on the value of X and the value of Y at the time when you're standing here. So sometimes you will follow this path here because it's labeled true, or it's basically saying if the expression is giving you a value of true, follow this path. If the expression is giving you a value of false, follow the other path. Are we doing okay so far? If you follow this path, and there will be a little block here where you can do something. Okay, I'm sure most of you have gone to a trail where they have like exercises along the trail. Like different types of facilities and whatnot. So this is one thing. It says Z gets the value of X. Okay, and then the other one you have a different activity, which is Z gets the value of Y. Okay. But since you can only be at one place at a time, so you'll be either executing this statement or the other statement, but not both at the same time. But both of these little activities will merge, and you can exit at exactly the same point, regardless of which way you go at the split. Are we doing okay so far with this picture? Okay. Now, for those people who are listening to the lecture because you're just reviewing it or whatnot, it's actually in the notes already, so it's okay not to record this part because it's already in the notes. So let's go ahead and go up. And I have a picture here already. Well, a picture and also the pseudocode. So what we'll do in class, because we have the whiteboard having the picture there, we're going to compare this code here, okay, listing 1, is the text representation or the pseudocode representation of the logic represented by the trail map. It's exactly the same logic, okay? If X is greater than Y, Z gets X, else Z gets Y, and if. That's the pseudocode representation. In other words, every time you see the code that is highlighted on the projector, in your mind, it should remind you of the logic represented by the trail map. The trail map is easier to read because, with all the arrows and, the way that we understand how to read a map, we automatically kind of understand, what this means. The pseudocode is a little bit harder because it doesn't tell you, it doesn't have arrows, pointing out, okay, if it is true, go this way, if it's false, go the other way. But yet, it is still using a lot of words that we use commonly in English and in the same context, except for the else-if part, which is not, usual in regular languages. So do we have any questions, corresponding the pseudocode structure to the trail path, that I just drew? No questions? Okay. It's only about this week and possibly the next one that I'll draw pictures about the pseudocode or the logic, because after this I'm just going to use pseudocode. So you will have to kind of do the mapping yourself and understand when I see the pseudocode, it means this kind of logic. And if you read the notes, there's a line by line explanation of what each line is doing. So I'm not going to go over that. What I will do is to talk about the general format of a conditional statement. The general format of a conditional statement is going to look like this. You come in from the top, you have a condition to evaluate. The condition, after evaluation, it will give you either a value of true or a value of false. If it gives you a value of true, you follow the path that is labeled then. If it gives you a value of false, you follow the path that is labeled else. And in each case, you will do whatever is specified here or here, and then you proceed to exactly the same point to get out of the conditional statement. So that's the general format of any conditional statement. And as I said a little bit earlier, this trail map is already captured here in the notes. So so you don't really have to copy anything from the whiteboard because it's already here. All right. So at this point, we have seen the logic itself. We have seen the pseudocode representing the logic. We talked about the general logic. It seems like we have a pretty good understanding of the logic. So it's time to talk about how are we going to trace these algorithms involving conditional statements. So we'll go ahead and take a look at that. And I'll give you an example first, and then I'll go over the convention in a document that is already on Moodle. Okay. So I'm going to use an example that is not going to be the same as your homework assignment, nor the example that is already in the notes. So I'm going to do something along this line here. So I'll say if x is less than 0, then do the following. X gets the negation of x, or if you prefer, 0 minus x. Else x just gets x itself, which is not useful. Okay. But I'm going to put it there anyway, just so that I can show you how to perform a trace. Okay. And we have line numbers. And we'll go ahead and trace it now. So I'm going to use a new window to look at the trace, because I'm going to use the other one just to look at the algorithm. The first thing about when you're tracing anything that involves the evaluation of a condition, like in this case on line 1 we have a condition to evaluate, you will need an extra column, because I want you to tell me why the program is choosing one way or the other. Okay, so you will need an extra column for things like this. So from now on, if you see that you have a conditional statement, and later on with loops, you need a column called comments. Okay. Comments means it's not documenting something that is really a change to the variables, but rather it is something that you want to annotate. Okay, it's something that you want to tell me or something that you want to track, but it really is not changing anything in the program itself other than the path that you're taking. We still have the usual line number because we need to know which line is doing what. And we still need one column for each variable. So all the conventions that we talked about before, regarding that are applicable to assignment statements, still applies here, except that we have a new column called comments. The precondition in this case cannot be a question mark. In other words, x cannot start with an unknown value, because otherwise there's no way I can trace the algorithm. If x is unknown, I cannot tell whether x is actually less than 0 or not. So this is one of the many cases where I will give you an initial value for the variables, just so that we can continue with the trace. So in this case, I will start with something like maybe x starts with, let's say, 10. Okay. So that's my precondition. Don't ask me why x is starting with a value of 10. It is just given to you before line 1 starts. Is that okay? All right. Yep. Go ahead.
If it wasn't given to us, it would be a question.
If it is just a question mark, then you have to basically say there's no way to proceed with the trace, because there's no way to evaluate expressions involving that particular variable. Yep.
How do you portray that?
Say
How
again?
would you say that there's no way to?
You just write it in the cell. Yep. But only when you get to a line where it is trying to refer to an unknown value. So in this case, it is line 1, but in other cases, maybe you're already, you have gone through a few lines already before you get to the point and say, hey, this variable doesn't have a known value. I cannot proceed from this point. Okay. All right, so now we are ready for line 1. Now, line 1 is kind of interesting, because if you look at it from the perspective of, okay, which variable is getting changed? None is getting changed. Okay, it's not an assignment statement. Every assignment statement is going to update a variable, the one that is on the left-hand side. So there's always something to say about the result of an assignment statement. in the column of the variables. In this case, there's really nothing to say because all I'm doing here is to compare x to 0 and see whether x is less than 0 is true or false. So that's why, when I look at column C, nothing is happening. X still has a value of 10. And from now on, if we are not changing the value of a particular variable, you can just leave it blank, because otherwise it will get very tedious, down the line. So we are just going to change the convention a little bit here. If you still want to put a 10 there, I'm not going to take any points off. That's okay with me. But if you want to say, well, that's really kind of tedious, so unless I'm making a change to a variable, can I just leave it blank? The answer is yes. Okay, you can just leave it blank when you're not updating the variable. But here, the most important part is in the on the column of comments. Now you have to tell me two things. Okay, the first thing is you have to repeat the expression in the conditional statement the way it is. Okay, so on line 1, the condition is x is less than 0. So you have to repeat that condition here and say x is less than 0. Well, what is the whole point of doing this? Well, the second part is the important part. You have to tell me whether that expression is true or false based on the current value of x. So what do you think? Is it true or false?
False.
It is false. All right. And we don't spell out the entire word, just so that we can save some space. Otherwise, this column gets a little bit too wide. And as you can see, we can make it a little bit thinner now. So I'm going to make it a little thinner. All right. So if x is less than 0 is false, then where are we going? We have to go to the else part. Now, this is also the convention of this class, is we do not trace line 3. The purpose of line 3 is only there as a marker to separate the then branch from the else branch. But as far as execution is concerned, line 3 doesn't do a single thing. And as a result, we do not trace line 3. Okay? We don't trace line 3. It is only there as a marker and say, hey, this is the beginning of the part to execute when the expression is false. But otherwise, it doesn't serve any purpose at runtime. When you're actually running the program, it doesn't do a single thing. So that's why we start with line 4 when we follow the alternative branch. Are we doing okay so far with this convention? I know the urge to trace line 3, but it is not going to do anything. So that's why we don't trace it. On line 4, we have an assignment statement. A really kind of trivial one, because the right-hand side is x, the left-hand side is also x. So we look at the current value of x, which is 10, and then we say, okay, that's my right-hand side. I would use my right-hand side to update my left-hand side, which is also x. So x is now getting updated with a value of 10. Now, in this case, you do have to put a 10 here, even though it is the same value as before. You still have to put a 10 here because it is a write operation. So any write operation has to be documented. Yep, go ahead.
So if for number 1 you put it was false, so that means you skip the next one, or you skip the rest of the column?
Because you are coming in, the condition evaluates to false, so you have to follow the path that leads you to the else portion of the conditional statement. So that's why you're, quote unquote, you're not really exactly skipping line 2, you choose to execute the other branch, which is starting on line 4. Well, in this case, the other branch only has one single statement, but potentially you can have a gazillion lines between line 3, the else, and the end if. In this case, there's only one. Yep.
Is else the only statement that we would skip in the trace, or do you ever have comments in your trace that we would have to also skip?
Well, it'll be made clear later. That's a very good question. For your homework assignment, there's another line that we don't trace, and it's coming right up. Okay, so after line 4, we are at the end of the else branch. In other words, we are kind of right here. So what do? We merge with the other path, which is not documented in the trace, and then we proceed to get out of the conditional statement. So most people would think, well, maybe we should indicate line 5 here to mark that we are now at the end of the conditional statement. But and if doesn't do a single thing either. Okay, it doesn't affect any variables. It also does not alter the path of execution, because it's really just saying, hey, this is the end of this particular portion of the program. But we still have to move on. So that's why line 5, the end if line, is also a line that we do not trace. We just don't, put it into the trace. Yep.
If there was a conditional within a conditional, would we have to specify that?
If it's a nested conditional statement, we still do not track that. So you have to do both exits, without any notation. There's a reason why I do not trace the else or the end if. It has to do with when you're dealing with loops, the end of a loop is ambiguous because when you are on that line, do you mean that you are ready to get out of the loop, or do you mean that you're at the end of the loop and you're ready to go for another iteration? So that's why I do not trace the end of a construct because the meaning can be ambiguous in certain types of statements. So without tracing line 5, I'm done, right? I mean, this is the only statement, the conditional statement is the only statement in this algorithm, and I'm done with it. So at this point, I can just say post, and I'm all done.
Now,
okay.
What do you put in the comments on line 4? You don't put anything in?
No, nothing in comments, because line 4 is a regular assignment statement.
Oh.
So we trace an assignment statement as before, the same way as we talked about on Tuesday and before Tuesday.
So only put it if,
Oh, sorry. Go ahead.
so you only put it if it's true or false, if it's asking you a direct statement.
Correct. Comments at this point is only used when you are evaluating a condition in the context of a conditional statement, or later on in this class, a loop.
Oh.
Yep. Go ahead.
What if x would be -2?
Well, we'll trace and we'll make another trace to handle that case. Okay. But are there any other questions about this particular one? Yep.
What if it's true?
What if it's 2?
No, true. Like
True?
X.
Well, that's what she was asking too. So I'm going to give you another trace for the same algorithm, but starting with a different precondition. Okay, that's a good question. Any other questions about this particular trace? Yep.
What is exactly the end if used for? Like,
Well, end if is useful when you have nested statements. Then it is very important to indicate this is the end of what. The purpose of the end if is kind of the purpose of the closed parenthesis when you have parentheses in an expression. Okay, so there's one to mark the beginning, which is the if, and there has to be another one to mark the end, which is the end if. Without the closed parenthesis or end if construct, it becomes difficult to understand nested structures when you have a conditional statement inside a conditional statement. So that's why we have a seemingly redundant, ending, mark here is as end if. For those of you who know Visual Basic, this is actually what Visual Basic does. Yep.
Is there any way you can write that using that? Like, for example, there's this x is less than 0. On the little sign up there,
Yeah.
it would, if you write that.
Can I write that?
Yeah.
Well, this would have exactly the same structure as what we see here on the whiteboard, except the condition becomes x is less than 0 question mark, and then on the left hand side we will have x gets 0 minus x, and on the right hand side we'll see x gets x. But the structure remains exactly the same. The framework remains exactly the same. We're just changing the little pieces in between. So the key, okay, so I think I understand your question. The key is this. The key is you have to be able to map this thing here, and I'm going to use the Scratch terminology here and use shapes to record different portions here. And there's a portion of code here, there's an else, and I will use color coding to indicate the other block here. And there's an end if here. Okay, so if you see something like this in the pseudocode, in your mind, you will have to reconstruct this to represent the logic that looks like this. Okay, incoming path like this, but the question, the hexagon, will go here. Okay, there will be 2 paths. One path to represent what you do when the expression is true. The other path represents what you would do when the condition is false. This one will lead to the black rectangular block, which is representing this block of code here. The other one will lead to the blue block of code, which is representing the block of stuff that is between the else and the ending. And then the two paths will merge before we get out of the entire conditional statement. That's basically the template that you have to make and be able to map in your mind when you see the pseudocode. Is that okay so far? You see something that looks like this in pseudocode, you have to be able to map it to the logic represented by this picture. But I would personally would not use pictures unless it is necessary or at the very beginning of this class, because the pictorial representation of algorithm is easy to understand, but it runs out of gas really quick. Because it's huge, it takes a lot of space, it's actually very time consuming to do it this way. And that's why we in this class really have to train ourselves to try to use pseudocode as quickly as possible.
Professor?
Yep.
Why is it false?
Huh?
Why is it false?
Because x has a value of 10, 10 is less than 0 is false. Okay?
So in a way, for that, you're just saying we put any number greater than 0 makes that means
It will follow the same path, right? Any number that is greater than or equal to 0 will follow this path, the path that we have shown here.
Isn't it equal to does not come into play here because there's no equal sign, just less than?
Well, let's have two more traces, okay, to handle the other two cases. Okay, so are we done here with the case when x starts with a value of 10? Yes?
Professor, so it's x less than 0 minus x. So if you plug 10...
We're not there yet, okay? We're not there yet. We did not execute line 2 here. So let's not worry about line 2 when we don't step on it. When we step on it, then we'll think, is that a mine? Should I step on it? But since we're not even walking in that way, it can be a minefield, and I don't care a single thing about it. Okay? So the next test case, we'll step on it. Okay? Then we'll figure out what's going to happen. Okay? Any other questions about this particular trace? This specific trace when x started with a value of 10. Yes? Sorry?
How'd you find the value of x?
It was given to you. Remember I said don't ask me? It was just given to you for this trace just so that I can demonstrate what happens when we follow the then branch. Yep.
Is our homework gonna give us the value?
Yes.
We don't look like, okay.
Absolutely. So if you look at your homework assignment on sheet 2, x, y start with the values 2 and 4, 4 and 2, and 2 and 2. Now z has an unknown value, but it's okay for z to have an unknown value because we never refer to the value of z, and that's why it's okay for z to start with an unknown value. Okay. Good questions? Yep.
Now, if you want to write out your trace, you just create another sheet next to it. On
Yes.
the tab.
Yeah. In classes, I just create another sheet, and trace the other
For
in
your
the other
homework
sheet.
assignment.
For the homework assignment, it's already pre-done for you. Okay. Sheets 2, 3, and 4 are already in the document. You just have to switch to that sheet and perform the trace, and then that's basically what you do in your homework. Yep. Sorry. Attendance, very good. Okay, I keep forgetting that. So here's a question. Why do you guys think that I keep forgetting the attendance?
So excited about programming?
Sorry?
They're so excited about programming.
Pretty much. I know some professors are really diligent about remembering row sheets and stuff like that. I just cannot remember things like that. Okay. All right. Any other questions? The proverbial absent-minded professor. Yes. Go ahead.
No, besides me, how long it took you to get where you are now? How long it took you to get to where you are now?
How long does it take to get to
Being a professor.
being a professor?
Yeah, no, the degree you got.
Oh, the PhD and stuff like that?
Yeah.
Well, the PhD is really just a piece of paper, right? I mean,
I mean to understand at your level.
Oh, this stuff here?
No, what you currently do, like understand exactly how to program.
It just takes, I would say, okay, so the question was, how do you become, basically,
Proficient.
quote unquote, well, I wouldn't call it proficient, I would just say proficient as I am now at this point. And typically for a person, you have to go through a 4-year program in computer science. So here you will spend about 2 years depending on whether you can get into classes that you need, right? So 2 years here, and then after you transfer, about another 2 years at a CSU or a UC. So you have a bachelor's degree at that point, which gives you all the foundation, the fundamental stuff that you need in order to do programming and stuff like that. This stuff is really kind of elementary, so by the end of this class, you should know this stuff already. But to get a job, okay, in computer science, as a software engineer, as a developer, as a computer scientist, you need to have at least a bachelor's degree. You can actually do programming before you have a bachelor's degree. That's not a problem. The question is, do you understand enough about computer science and all the knowledge that you're supposed to know to move and learn and grow by yourself? That's the question. You can learn programming just by reading a book, right? I mean, you don't have to take a class. You don't need a degree to learn how to program. I can learn French if I want to just by reading a book, right? But would that make me a good, fluent, French speaker? Probably not. Okay, so that's really the thing. I mean, you have to go through, the education to do that. For those of you who have the luxury to go for graduate school, I highly recommend at least getting a master's degree in computer science if that's what you want. Okay, computer science and programming is the kind of stuff that you want to do. The reason is a lot of companies have a quote-unquote glass ceiling for people with a bachelor's degree, and if you have a master's degree, you can actually go a little bit further, on the ladder, and it actually gives you the advantage. Now, as far as PhD is concerned, it's a toss-up. Okay, it depends a lot on where you're going. If you're going to work for, let's say, Google or Pixar, or one of those, companies where research is really, important, then having a PhD helps. Definitely helps. Okay, if you're working for a company where they just want you to, sit down and start to code stuff, okay, like let's say Facebook and some of the other companies, then the extra time that it takes to get a PhD is quote unquote not worth it unless you enjoy the process. Because having that PhD is not necessarily going to help you get a higher salary or go further on your in your career path. But a master's degree typically will help because it's a more pragmatic kind of degree, whereas PhD is usually more theory. You're living in an ivory tower, and in some cases it would be counted against you too, because some companies have a preconception or prejudice that PhDs can only do research paper, but they cannot do a single line of code. So is that answering your question?
Yeah.
So 4 years in undergraduate and about 2 more years in graduate school would get you your master's degree. All right. So let's go ahead and look at another test case here. So I'm going to be a little bit lazy and just do a little bit of copying and pasting into sheet 3. But I'm going to start with a different initial condition. So x in this case will start with a value of, let's say 0, okay? Because I think that's actually considered a little tricky in this case. All right, so I'm setting up all the windows here so that once again we have the algorithm on the left-hand side, and then we have the trace on the right-hand side. Okay, so let's go ahead and get started with this one. When we trace an algorithm, we always start with line 1, at least at this point. So on line 1, once again, it is a if type of statement. It starts with the word if. So we have to indicate the condition and also the value of the condition once we evaluate it. So we have to start with the condition itself, x is less than 0, is, well, let's think about it. Is 0 less than 0?
No.
No. so it's false. Okay. So if this is false, according to this picture here, if the condition is false, we follow the false path, which means we execute whatever is between the else and the end if. In this case, we only have one line over there, which is line 4. So the next line is line 4, and we are going to execute that statement on line 4, which is an assignment statement. The right-hand side is x. X currently has a value of 0, so the entire right-hand side is just the value of 0. The left-hand side is x, so we update x to a value of 0. And because that's the only thing we do, in the else branch, and this is the only conditional statement, the conditional statement is the only statement in the entire program, so we got nothing else to do. It is time to say, I'm done. So are there any questions about this trace? Or the fact that 0 is not less than 0, or 0 is less than 0 is false? Questions about that? Yep.
Can we do one with a negative?
Absolutely. That's the third one. Okay, good idea. I like questions like that, because it kind of helps lead me to the next slide or the next step in the process. So I'm going to do another one. And once again, I'm going to copy and paste a little bit so I don't have to reformat the columns and stuff like that. But in order to do this one, I'm going to change. I have to delete some of the cells because the path is going to be maybe a little bit different this time. Okay. So this time we'll start with a negative value in x, -3 to be exact, and we are now on line 1 again because we are starting to trace the program from the very beginning. So once again we have to indicate x is less than 0 is what? True. It's true, right? -3 is less than 0 is true. And where are we supposed to go? Well, look at the picture here. If the path is true, we go to the block that is between the if and the else, the then branch, basically. So in this case, which line is corresponding to that? Line 2, very good. And what is line 2 doing? Well, let's look at the right-hand side first. The right-hand side evaluates 0 minus x. What is 0 minus -3? Just 3, right? Okay. So 3 is the value on the right-hand side. The left-hand side specifies x as the variable to be updated. So now we update x to a value of 3. Do we have anything else to do between if and else? Nothing. Do we have anything to do after the conditional statement, after and if? Nothing. All right. We are done.
You leave line 1 blank.
Huh?
Blank, the one next to what the x value is.
Because we are not modifying x.
Oh, okay.
Right? Line 1 doesn't change anything. All it is doing is to evaluate an expression. Yep.
You said you don't mind that we do put a -3.
If you put a -3 there, I'm not going to take any points off, but it's not necessary. Okay. Yep.
Isn't it supposed to be -x, -3?
Nope.
Why not? 0 minus 3 is negative.
0 minus -3 because x. Okay, when we go back to line 2 here, at the time of line 2, at the time that we evaluate the right-hand side, x has a value of -3. 0 minus -3 is
-3.
no.
Positive. Positive cancel.
It's +3. If I just let me just write it out because when I say it, it's not as easy.
Oh yeah.
Okay, all right. Any other questions about this trace? No questions? Can someone tell me what this algorithm is really doing? Is there a mathematical operation that will do exactly what this algorithm is doing? Yep.
Is it the absolute value?
Yep, it's just taking the absolute value of x, or x gets its own absolute value. That's the outcome or objective of this algorithm.
So if you put less than equal to 0 instead of less than 0, it would be the same.
It would be the same because the negation of 0 is 0 itself. Correct.
Just like a calculator pseudocode.
It's taking the absolute value of something. Are there any other questions about this algorithm or the 3 traces that we have done so far? No questions?
No.
Okay. Yep, go ahead.
Now if it's negative, you just go past, skip line 4.
We're not skipping. Remember, we are choosing which side to go, and so it's not like we're skipping it. We are just choosing to execute one branch and not execute the other branch. So you have to remember the pseudocode representation looks like this. So it looks like we are skipping this portion here, but when you look at the logic, we are not skipping. We are just choosing to run one side, to use one side of the branch and not the other side. So when you look at the pseudocode, like in text mode, it looks like we are skipping something, but logically speaking, we are not skipping something. We are choosing one of the two branches. So it's kind of important because it sounds like it's the same thing, but it really is not. Okay, any other questions? No other questions?
I did.
Okay, go ahead.
Huh?
Oh, no questions? Okay. All right, if there are no questions, I'm going to be very boring and basically just go over the conventions that we have been using for all three traces up to this point. Because I just want to make sure that people understand what I will be expecting in this particular homework assignment. So this is the slide that talks about the convention, and I'm really hoping that people will find this to be extremely boring because, yes, we get that already. We have been talking about this for the entire class. So, but I do want to make sure that we, get it. So here comes the boring part. The column labeled columns must be present and be at the leftmost column immediately to the left of the line number column, which is a really long way to say this. Okay? What? I forgot.
The other one.
The other one. Okay. How about that? So it's just a long way to say this column here. Okay. The line containing if or else if, we haven't seen any else if yet, so don't worry about it for this particular homework assignment, must be traced. All right, so for that means, okay, let me switch to the source code too. So this line has to be traced, and this is the result. Row 3 of the trace is the result of tracing that line. When such a line is traced, the comments column reflects the result of the condition. Okay, but I'm giving you more details. I don't want people to just give me true, false, or something that I'm not expecting. So this is the exact thing that I want you guys to do. Use this to log the condition evaluation in this format. Okay, you put the condition first, and then you say is, and then either true or false. Okay, that's the format. So if we look at a particular case like that, this is an example. X is less than 0 is exactly the way it was written in the pseudocode itself. So you have to basically copy the expression or the condition from the conditional statement as the first part. And then you say is. If you forget to say is, that's okay. I'm not going to take any points off. But you do have to tell me the result of that condition when it is evaluated at this point. So it's either true or false. Okay, so you do have to indicate whether it is true or false. Yep.
Now, if this is actually a trace program, if you forget to put that is, will it mess it up?
Because I'm the one grading it, and I can definitely just say, well, okay, you mean the result is true, or you mean the result is false. It's okay with me. And that's why we're using pseudocode, so it's not really as strict when compared to when I grade it with a program or with a script. Then you have to be even more exact. Yep. All right. So getting back to here, this means the comments column must contain the condition as specified in the pseudocode. The result of the condition must be indicated as true or false, one or the other. The lines containing else by itself or and if are not traced. These lines exist only to separate or terminate a construct, which means it is useful as a marker, but it's not doing anything at all when you execute the program, and that's why they are not traced. All conventions already mentioned in tracing assignment statements are still effective, with the exception that there is now an extra column called the comments column. So are there any questions about the tracing convention? Anything that I mentioned here that is contrary to what I did in this class? Nope. Okay, so I'm going to use that as a part of the grading standard for this homework assignment. Okay. Any other questions regarding the homework assignment? No questions? All right. So now that we are done with the most basic conditional statement, it's time for us to move on and think about, well, what about something that's a little bit more complicated, okay? So instead of showing this code to you, I'm going to just move on to the next slide first, okay? So let me pose a new problem, okay? Instead of having two variables, and I want to find the maximum of those two and assign it to the third variable, now I have three variables. I want to find the maximum of three variables and use the fourth variable to store the maximum of the three. Are we doing okay so far? So I have variables w, x, and y given to me. They all have values already. I want to find the maximum value of these three and then use z to store the maximum value. Okay, so that's my new task. I know I can handle two, so now the question is, how do I handle three? Okay, there are many ways to do it, but one way to do it is to use a multi-branch conditional statement in conjunction with logical operators. So we'll go ahead and talk about logical operators first, and then we'll go back and talk about what is a multi-branch conditional statement. So the first logical operator is called conjunction. A conjunction is an operator that has two sides. The entire expression is true if and only if both sides are true. So that means true conjunction true is true, false conjunction true is false, true conjunction false is false, false conjunction false is false. Sounds really complicated. Well, guess what? We do have a word in English that means exactly the same thing as conjunction in this context, and it is and. We actually have another word in English that means exactly the same thing as and. It is but. Okay? B-U-T actually means the same thing as and. Think about it. Think about it. So I'll give you an example, and a really kind of obvious example. Okay, here's a good one. Tech seems to know a lot about programming, but he's kind of short. Okay? Okay, so think about this statement here. Is the statement saying that I know something about programming and I am short, or does it mean that I know something about programming or I'm short? It's both, right? I know something about programming and I'm short. So the word but actually means the same thing as a conjunction, as an and. We only use that word when it's something that's contrasting. Okay? And we just want to emphasize, okay, but contrastingly, da-da-da-da, okay? Something that is not usually expected, after the first part of the statement. So when you look at, English that way, there are two words that mean exactly the same thing as a conjunction. So conjunction, as defined here, okay, this is the caret symbol, is the mathematical symbol for and. So if you read the rest of this document, the mathematical symbol of conjunction is kind of like a TP or an inverted V. In C and other C-derived language, it is a double ampersand symbol. In Pascal and some other languages, it is just simply spelled out as and. So this is also a good place to tell you that if you use a single ampersand in C++, it is a different operator. And in all cases, not some, in all cases, where you can use a double ampersand as a logical operator, you can also use a single ampersand, which is a bitwise AND operator. They mean almost the same thing, but not quite exactly the same thing. In other words, if you make a syntax error or if you mistype in the program, instead of using double ampersand and you put in a single ampersand, the compiler cannot detect anything wrong is wrong with your program. It looks almost right, but it will do something that may be wrong occasionally. So those are the things that you really have to observe, because they have operators that look almost exactly the same. It's easy to mistype, and yet the compiler cannot catch it. The behavior of the program is going to look right for the most part. Only occasionally it will be incorrect. Okay, and that's why C and C++, they are really not programming languages for instructional purposes. They're really poor choices for that, because there are lots of traps involved in C and C++ programming. Before you move on to cisp300, I'm assuming most of you are moving on to that class. You might want to read this book, or at least get someone or get a copy of that. It's I cannot remember the name. C++ programming, rope, shoot, cell. Okay, that should be enough. There we go. Obviously, it's not a very popular book because it only has 3.5 stars, but the title should tell you something about C++ programming. Enough rope to shoot yourself in the foot. Rules for C and C++ programming. Things to watch out for. Okay, because compared to Pascal and some other programming languages, C and C++ are definitely have this attribute. You can't shoot yourself in the foot pretty easily programming in C and C++.
That's why I hate Unix. That's why I hate Unix.
All right. So this is conjunction, and we have enough time to finish up this, all 3 operators. The second one is disjunction, and the definition of disjunction is given by these 4 bullet points here. True, disjunction true is true. False, disjunction true is true. True, disjunction false is true. False, disjunction false is false. Well, guess what? That's just a fancy word of or. Okay? But you have to be careful now, because or is not the same thing as either or. Okay? When we use the word either or, when we have the word either, it is what we call an exclusive or operation. Okay? This is just a regular or, not an exclusive or. Do we have any questions about this slide? About the meaning of the word or in English. So or is going to join 2 things, right? You have a Boolean expression on one side, you have a Boolean expression on the other side. The result of the disjunction, or the or operation, is true if and only if at least one of the 2 sides is true. Okay? So you can kind of imagine there's a sign at the door, okay? And it says, only professors or enrolled students may enter. Okay? So can you enter, when it's time for this class? Yes, you're a student in this, enrolled student in this class, but you're not professor. But remember, with a disjunction, you only need one condition, at least one condition to be true to get into the class. Is that making any sense? Can I enter this classroom when it's time for this class? Sure, even though I'm not an enrolled student, I am the professor of this class, so I meet one of the 2 requirements, at least one of the 2, okay? So I can enter this class. So what if the enrollment of this class is kind of low, and I kind of say, well, I kind of need to boost the enrollment, so I'm going to enroll in my own class, so I'm both the student and the professor of this class. Can I enter the classroom?
Yes. Absolutely,
because the requirement is I only have to be at least one of those 2, right? If I'm both, it's still okay. So that's the meaning of or in ordinary English, and it's called disjunction in programming. So the symbol looks like a V symbol, and then it's also a double bar in C and C++. Yep.
That looks like a
Same
Boolean.
thing in conjunction. If one is false, then one is false.
Yes, you can look at conjunction in 2 ways. You can look at conjunction or and as it is true if and only if both sides are true. You can also look at it from the perspective of it is false if and only if at least one side is false. And the last one is negation. Okay, negation also has the most popular way to refer to negation or logical negation in English is not. Okay, it's just the word not. Of course, these days we also use the word ain't to mean negation. A-I-N apostrophe. So negation is easier. If you look at the definition of negation, over here it only has 2 lines because we can take the negation of only a Boolean value, and a Boolean value can either be true or false. So over here we're basically saying ain't true is false, and ain't false is true. Okay, never mind. Not true is false, not false is true. Because it's just negation. It's just turning it to the other side. Is that okay so far? Any surprises, with the previous 3 slides? and, or, and not. But together, those three logical operators can be used to express complicated conditions. So we'll take a look at this next week on Tuesday. We'll take a look at how to use these logical operators as well as multi-branch conditional statements. So your job is to finish reading this document so that by the time we get to next Tuesday, you guys have an idea of what I'll be talking about already.
I was wondering, what does this guy have to do with mechanics?